In this video, we're going to look deeper into the concept of statics by looking at stress, strain, and how they relate to another term called Young's modulus. Let's say we have a wall. Attached to this wall is some sort of string, rope, or rod, something that we can pull upon. We're curious how much this object stretches or elongates when we pull upon it. What is the change in length? We might ask, what is this object made out of? Is it rubber, rope, steel? But I'm not going to tell you that just yet. So let's try to get a little more specific about this. What is change in length, delta L? Well, let's write an equation. We can guess that perhaps a longer object would have a greater change in length. So we could put an L on the top of our equation that we're creating. Now what might make it stretch less? We can guess that a thicker object might stretch less, something with a greater area. We measure this for a diameter of 0.85 centimeters, but we're really concerned with the area, because a square rod doesn't have a diameter, and area is a more universal term. The last thing that really matters is the force we're pulling upon. A bigger force would lead to believe that there's a bigger extension, so we'll put force on top. But we still haven't accounted for what it is. This is where Young's modulus comes in. Young's modulus is a number that applies to any object in specific, similar to the coefficient of friction we learned about earlier. So a rubber band has some specific Young's modulus, and steel has some specific Young's modulus. Young's modulus is defined by the letter E, which we'll put, for now, on the bottom of the equation. This might seem like a strange choice. It could be on the top just as easily, and the top is generally more fun. But it'll work out better if we put it on the bottom now. This is a convention. We could just as easily put it on the top. Okay, now we're going to see the reason for putting Young's modulus on the bottom. Let's rewrite the equation trying to get Young's modulus by itself. This will make everything a lot easier to look with and a lot simpler to think about. We'll define stress as force over area. Stress is a similar concept to torque. They both have to do with the effect a certain force has. If you push on the doorknob handle, that's going to have much more effect than if you push near the hinges, even if you use the same force. With stress, if you use the same force on two objects, but one is much thinner, then you'll apply much more stress to the thinner object, much less stress to the thicker object. Strain is a little bit different. Strain has to do with the change in length over the total length. A rubber band will have a lot more strain than a steel rod will, because you'll need a very big steel rod to get anywhere near the same stretch you get in a rubber band. Young's modulus is interesting because it simply reduces to the stress over the strain. Young's modulus is a simplification. It attempts to take into account all the dirty chemistry and molecular energy that physicists don't want to think about. The reason it works out so well is because Young defined it carefully way back when he did.